Hi, today we're going to talk about the capabilities of Stargate GraphQL API. I'm Krishna Narayanaswamy and I'm based out of Melbourne. I started my career as a software R&D engineer and I've built a number of great products across different organizations. I specialize in APIs, cloud native technologies, databases, streaming platforms, and Kubernetes. What is GraphQL? GraphQL is an API query language and a server-side runtime that allows us to transfer data between applications. Originally created by Facebook and then open sourced in 2015. GitHub uses GraphQL and they announced in 2016. Another example is Netflix uses Cassandra and GraphQL together to serve extremely fast answers to specific questions that their consumers are asking from their mobile devices. GraphQL is becoming very popular HTTP-based API nowadays. One of the primary reasons is the client applications declare the data they want in one call, and they don't have to care how the backend systems retrieves that information. Now, this reduces number of network round trips, and the client is in control of the data that is being transferred. It reduces overfetching and underfetching data with other APIs such as REST. Now, when the application evolves and when new fields can be accessed through the API without modifying the application code or the logic. GraphQL also allows aggregating data from multiple sources with one API endpoint. This pattern is often called as data federation. Now, applications can literally minimize the number of requests using GraphQL, right? A good example of where it can be used is mobile or IoT applications where using less bandwidth or saving battery really matters. Another example is when an application needs nested data to be fetched in a single call. For example, a blog or social media networking platform where posts need to be fetched along with nested comments and commenters' details, for example. Let's look at how we would implement GraphQL. Now, what you see on the slide there is that the client is actually specifying exactly that they need title from a model incoming workshops, for example, or from the table that stores the workshop information. Now, a query is a read-only dialect which used primarily to fetch data from the server using GraphQL SDL syntax that you see there. Now notice that we can also pass parameters, especially date that you see on the slide there. Other capability is that the GraphQL system or type system allows with built-in scalar types like integer, float, string, Boolean, ID, and also user-defined types. Now you can create structure with constraints here, right? Now, this is very, very important. So it's kind of a tight schema where you can have number of different validations on operations that the client is performing. When we speak on operations, so mutations are the key here, right? So they are used to change any resource data or execute an action on the server. Now, in today's demo, we are going to see Astra DB, right? So Astra DB is a SaaS offering from DataStax that is essentially Cassandra that runs on the cloud, and there's a Stargate API layer that sits on top of the database that allows you to query information. Stargate offers REST, GraphQL, and document API. So today we'll see the demonstration of GraphQL. And then there's also a playground, which we will see on the demo. So essentially allows you to interact and try out some of the GraphQL queries out there. Now the Stargate GraphQL API has two modes, right? So one is native GraphQL schema principles developed with the CQL, that is the Cassandra query language, in mind. The CQL-first approach directly translates CQL tables into GraphQL types, mutations, and queries. Now the GraphQL schema is automatically generated from the key space tables and the columns defined, but no customizations are allowed. Now, a standard set of mutations and queries are produced for searching and modifying the table data, right? So if you're familiar with Cassandra, you might prefer this approach. Now, there's also another approach, which is the schema-first approach that allows you to create GraphQL types, mutations, and queries in a manner familiar to GraphQL developers. The schema is developed and can be updated by deploying new schema without recreating the tables and columns directly. We will see both the approaches in the demo today. Now, what is sort of the difference between REST API and GraphQL, right? So in my opinion, GraphQL is a better REST, right? It naturally integrates with the REST ecosystem. Now, as you see in the picture, with REST API, you would typically gather data by accessing multiple endpoints, like players, teams in these cases, right? Now, with GraphQL, on the other hand, you would simply send a single query and then you can query data from multiple different tables in one call, right? Just optimizing network traffic and so on and so forth. Now, with REST, with number of different endpoints, you get to cache data per endpoint, but with GraphQL, you get one endpoint. So caching might become a little bit difficult, but at the same time, that can be solved through other tools like Apollo, GraphQL, and so on and so forth, right? But it is extremely easy for developers to onboard GraphQL into their development ecosystem, right? And the graph that you see there kind of illustrates what I was talking about. So as you can see, the GraphQL usage has been increasing over the last years. Now let's go and see a demo of what we have been talking so far. Okay, so this is DataStax Astra. So I'm just going to sign into the console here. I've already created the key space, which is essentially, and the Cassandra database already. So today we are going to use the GraphQL demo database, and it's got a key space GraphQL demo, right? So let's go ahead and create some tables now. So I'm going to navigate into the GraphQL demo key space, and I'm going to create a table. Okay, so I've already created. Let's insert some data into the table temp reading here. I've inserted one record, and I'm also going to insert another one. So let's make sure if we have got the data. So select star from temp underscore reading. So as you can see, it's pretty much like SQL, right? So that's the advantage of CQL. Now let's go into the GraphQL Playground. So what I've done is I've added the HTTP header, which is the Cassandra token, to interface with that database here once it's done. So I'm able to call and query. As you can see, with the list of key spaces, you get GraphQL demo as well. Now I'm going to create. So I'm going to go and query the schema now. As you can see, it's returned the temp reading schema in essentially the same way that we had created using the CQL in the console. Now I'm going to go into the specific GraphQL demo and issue a few queries to retrieve some data in here. So let's grab some sensor data with specifying the sensor ID here. And we are specifying that these are the values that we need to query. And we have got the two records that we store, right? So now let's go ahead and run some aggregations here. What we're going to do is we're going to do an average of both the values that you see there. So let's try now. So you can see that it has averaged out the sensor value there. We specify that we want to average here. Now let's try and insert some new data in here. So for inserting or updating, we use the mutations. So I'm using this a new sensor ID and I'm inserting a value 55, and it's already applied true. Now let's go and check if we have got the data that we inserted through GraphQL here. Okay, perfect. So now you see that there are 3 records. Okay, now let's go and modify or add a new table and see that it reflects immediately, right? So let's go and create a new table in our console here, CQL console. This is a new table, sensor info, and I'm going to insert new data into it. Okay, let's go back and query this from GraphQL Playground. Okay, so I'm just going to issue a query, and now I'm going to query from sensor info this time. As you can see, the sensor info data is retrieved from the table. Okay, so now we have completed the CQL-first approach. Now we are going to try and do the schema-first approach. So I'm going to change this to sort of the GraphQL admin so that we are able to issue some of the schema first. So here, we're going to create the GraphQL schema, and that is actually going to create the tables and everything underlying, right? So we came from the tables created through CQL and just calling from GraphQL. Now we're going to go the other way around. So this is the sort of the mutation. So where I'm saying deploy a schema in the GraphQL demo, and I'm saying that the table name is product and the query and so on and so forth, right? And I'm saying I want to be able to query by SKUs and category and so on, right? So let's go and issue this command. And you see that there is a new sort of version number for that schema generated. So I'm just going to copy this for my future use in the demo. Just one sec. Perfect. Okay. Now, so I'm going to go into sort of the mutation and insert some data into the products table. But before that, let's go and see if I've got the products table. Let's describe that out. So describe table and say product for that matter. Yes, so as you can see that the product table is already created through the schema that we created in here. So let's go ahead and insert. Now let's also refresh this and see our schema has got the product SKU name and all of that. Yes, perfect. They're all there. Let's go ahead and insert some data. So as you can see, we have inserted 3 SKUs. Let's try and query them now. So I'm going to query by products. Okay. So let's execute this. Yeah, so you see that it's returned SKU and name as we asked. Now we created an index on sort of the category. So we're going to pass that index into the GraphQL query saying category is electronics and see if we get the data. Yeah, so perfect. Now we're going to see by updating the schema, right? And now when we update the schema, automatically it reflects into our table schema as well. So we're going to see that now. Just give me a while I'm getting the command ready for it. Yep, perfect. Okay, so let's walk through. So I'm just going to do a dry run first to ensure if it's intact. So I've got the same version number that I had before, and let's do a dry run and see that now. So mutation deploy schema. Oh, I'm sorry, I'm doing it at the wrong one. That's good. Good to have validations. Let's go and do it at the right one where I need to be doing at the GraphQL admin. Perfect. So yes, so we are adding a new column rating as you see here, which we are updating the schema and also the query. So now let's remove the dry run and is all looking good. I'm looking good with the version. So now, yes, I got the version and the thing is updated. I'm going to refresh now and see if my schema is updated. Yes, I see that schema is updated too. Perfect. So let's go and query with rating now. If we are able to see the records. Perfect. I see rating null. That's expected. Perfect. Now we're going to see a bit of federation now. So I have a small demo prepared for that. So what essentially this is doing is that we've got the Apollo gateway on top, and then the like the products schema that we created and the table, and we inserted few SKUs there. So that data is going to come from the catalog service there. And I have another mock orders or Node.js which gets some dummy data. Now, this single query is going to actually get the products and also so it's going to get product, SKU, name, and category. So this category is going to come from the Astra database GraphQL endpoint, right? And the SKU and the names is going to come from that dummy SQL. So this is more of how you create a data federation. So let me go ahead and start the microservices in the background. Just give me a moment. So once I start, I should have the Apollo gateway started as well. Okay, I see that it's listening in port 4000. So let's go ahead and create a new tab, and let's maybe just park in with localhost 400, right? And then what I'm going to do now is I'm going to query the order ID 1 and then SKU name and category. And let's see if I can retrieve data. There you go. So the categories and other details are coming from AstraDB, and few static data is coming from the orders.js file, where there is a few hard-coded data in here, right? And then the rest of the other data is coming from from the Astra database. So thank you so much for joining me today. Hope you enjoyed the demonstration.